All right, so let's continue on this vein of our abstract function review. For problem number 4, the problem is very similar to the third one, but what's a little different this time around, let me expand this out a little bit, is that the function that we're dealing with, whatever function is defined to be, the domain is actually unlimited. There's a limiting part of the domain, a limiting part of the range, but it's unbounded in another set. So unlike number 3, where the domain and range are both bounded from the left and right or up and down, in this case we have something that is unbounded. And of course, to help us maybe visualize this, it's always probably good to do that. Maybe we draw a potential picture of what this function looks like so we can kind of basically see how it's being manipulated and transformed. So I have a range of 8 and above. So let's just, 2, 4, 6, and 8. Let's just say that's 8. So the function's starting here and going above, but then it's going from negative infinity up to positive 3. So let's say 1, 2, 3. All right. So how about we just say we have a point that starts here, and then maybe, it's a function that does, oops, that's the wrong way, right? It's because it's increasing like that. All right, so there's a function that basically satisfies the domains from negative infinity to 3, and the range is from 8 to infinity. Of course, it doesn't have to be this curvy line. It could be a straight line, right? It could be whatever you want it to be as long as it satisfies that. And so what's going to happen to this function as we go through some of these transformations? Well, in the first one, right, where we're at, we have x plus 1. Well, this means that we're actually shifting the domain 1 unit to the left. All right, so that means if this graph was going to be shifted 1 unit to the left, right, rather than starting at 3, it would start at 2, and it'd basically be the same graph. Or if you just want to manipulate the data, right, I'm going to take my current domain and I'm just going to simply subtract 1 from it. Subtracting 1 from negative infinity is no big deal. It's still negative infinity. Subtracting 1 from 3 would give us 2. So there would be our new domain if we shift everything to the left. Of course, you can get that feel from the picture. Here's the original function. If I shift it to the left, it'll start 1 unit to the left, and it'll just continue to move forward. In the next one, we have x minus 4. Well, this means we're actually shifting the graph to the right 4 units. So again, that would mean we'd go over 1, 2, 3, 4, and the graph would be over here, right? But just manipulating data, if I take my current domain and I'm adding 4 to everything, again, adding 4 to negative infinity is going to be chump change. It's still going to be negative infinity, but adding 4 to 3 would give us 7. And so you can see that our new function, right, would start over at 7 rather than at 3 because it's been shifted over 4 to the right. So that's basically what's happening there. Now in the next one, we're impacting range, right? There's our f of x, our y, and we're adding, 5 to all the y values. So basically we're shifting our range up 5 units. So again, picture-wise, that would be like taking this picture and moving it up 1, 2, 3, 4, 5, right, and it going up. Or you can just manipulate the data, right? So in this case, we have 8 to infinity, and I'm going to be adding 5 to everything. 8 plus 5 is going to give us 13. Infinity plus 5 is still infinity. So my new range would be 13 infinity. And again, let me move this down. You can see if this was my original graph, we've basically shifted that graph that starts at 8, 1, 2, 3, 4, 5. It's now starting at 13. And the graph would be up here somewhere. So we're moving it up as opposed to left and right, we're moving it up. As you can anticipate, in the next one, we're moving it down, right? So we're going to shift the graph down 7 units. So manipulating the data, I'm going to take my current range of 8 to infinity, and I'm going to basically subtract 7 from everything. And so that'll give us the new range 1, comma, infinity. All right, and carrying on, the next one, we still have our y values, but this time they're being multiplied by 2. So this means we have what I call a vertical stretch, right, by 2. So it's going to be, in terms of manipulating a graph, if this was our graph, right, it's going to get stretched out. It's going to get elongated in the x direction by a factor of 2. All right, oops, looked like I accidentally hit a key there. Okay, so I'll just basically take my range data, 8 comma infinity, and I'll multiply everything by 2. Well, 8 times 2 is 16, and infinity times 2 is still infinity. So the domain has been effectively stretched out, all right? And then last but not least, here we're multiplying our y values by 4. This is what I call compress, right, by 1/4. So I'm basically going to take all my x values, excuse me, all my y values, 8 to infinity, and I'm going to multiply by 1/4. All right, so 8 times 1/4 would give us 2, and infinity times 1/4 would still be infinity. So that would be our new range. So we've been compressed. All right, and for the sake of time, for letter G and letter H, now that I've kind of manipulated the data for you, right, I'd like you guys to have this conversation on Canvas. What do you think the new domain and range for this transformed function of this domain and range is going to look like? All right, so you guys have at that, and I'll let you guys discuss that, and we'll bring that class bring it to class, please. Okay. So in the next one, again, we got a new function, right? And the only thing we're told about it is that it has intercepts at -3 and at 4, 0. So again, let's try to give ourselves a nice picture of what seems to be going on here. So whatever this function is, right, it's got a x-intercept at -3, 0 and an x-intercept at 4, 0. So perhaps, for the sake of argument, maybe we're dealing with a parabola, right? So there's a potential graph of g of x. That doesn't mean it has to be the parabola, all right? I'm not clearly defining it. I'm just finding a picture. I'm just giving myself a concrete example of a function g with x-intercepts at -3 and 4, 0. So what are my new intercepts going to be if I multiplied the function by 2? Well, again, this causes what I call a vertical stretch, right? And let me go ahead and change colors here real quick. If we vertically stretch this, right, that's what that vertical stretch would look like, right? There's 2gx, but notice that the x-intercepts are actually going to stay the same, right? Because we're essentially, if we took a look at 2g of -3, this would be 2 times 0. We're still at 0, right? So multiplying 0 by 2 doesn't stretch it, make it longer, or make it more negative. It just continues to be 0. So in essence, since we're just elongating the function, we're not manipulating the x-intercepts. So the x-intercepts will stay the same for 5a. Let me go back to my black. All right, and so for the next one, though, we have a different transformation. That +5, it's impacting the domain, and it's actually going to be moving it over to the left 5 units. So that means this entire graph, right, this x-intercept's going to move over 1, 2, 3, 4, 5. I guess that will end up being at -8, 0, right? And this will move over 1, 2, 3, 4, 5, and this will be at -1, 0. And so that original g of x graph that I have will be shifted over 5 units. So it looks like my new x-intercepts are going to be at -8, 0 and -1, 0. Again, you can see we basically subtracted 5, right, from the x coordinates, all right, where we originally were. All right, and so there's your answers for 5a and b, either concretely looking at it or just manipulating the data. All right, and then last but not least, in number 6, this time we have a new function. It's called h of x, and the information that we're given is that it's increasing over this interval. All right, so again, concrete picture of what's going on. Here's 1, 2, and 3, 4, 5, and 6. So all I have to do is get a function. I don't know what this function is doing anywhere else, all right, but I do know that on this stretch of the x-axis, it's on its way up. All right, so maybe the function is doing something else somewhere, something else somewhere else, but for this stretch of data from 2 to 6, I know it's on its way up. And that's all we're going to basically be taking a look at. So for the first question, A, they're asking, on what interval would the function y equal h of x plus 3 be increasing? Well, again, that x plus 3 means we're shifting everything over to the left 3 units. So this whole graph is going to go over 1, 2, 3, there's -1, and 1, 2, 3, there's +3. So this graph is basically going to shift over -1 to 3. So the increasing action that we used to have at 2 to 6 is now going to be happening from -1 to 3. All right, and then last but not least, what's going to be happening to the graph of negative h of x? Well, this type of transformation causes a reflection, all right, about the x-axis. So let me change colors here. So if this is my original function here, right, and if we basically, this is h of x, then negative h of x is going to be on the negative x-axis. This point's going to flip down, this point's going to flip down, and all these data points are going to go this way. And so what we actually see is that for that new stretch, because of the flipping action we did about the x-axis, we're actually going to be decreasing. All right, so there is basically some abstract function concepts, all right, and along with transformations, and how to answer questions with that. What's happening again, should have mentioned this at the beginning, but we're basically taking truth statements, like this last one, right? Here's what I know to be true, and then I'm building new truth statements based off of what's offered and given. And that's a classic mathematical situation that occurs. Take a true statement and build new true statements from that. All right, so I'm about 12 minutes long here. That probably took longer than I wanted. You guys keep your review going up, and I'll talk to you later soon.